Thank you very much. Sorry about the technical difficulties. My voice is gone, so I will be quick, but it will be technical. So, first question. Who is using smart pointers? Hands up. Okay, so the talk won't be for nothing then. Sorry about automotive, guys. This will be all about dynamic allocation. So, before we start, just a quick recap how shared pointers work. So, shared pointers are managing heap allocated objects with reference count. What do you have when you have a shared pointer? Well, you have first your object allocated. In our case, let's take this struct A with a member and allocate it into a shared pointer which provides us reference counted memory management. Under the hood, the implementation, the shared pointer will create another heap allocation. We will talk about this in a second, which is a control block. This control block will have a pointer to the data, and your shared pointer will have a pointer to the data inside and a pointer to the control block. The control block basically has two things, the weak counts and the shared counts. When you have more shared pointers, object created, then your shared count will increase. When you remove objects from it, your shared pointer goes away, then the shared count decreases. The weak count is the same story, only difference is with the weak count that it is done so the destructor of your object is going to be called when the shared count becomes 0. And the weak count, when the weak count becomes 0, then your destructor of your control block will be called. Now, as you can see, if you allocate your shared pointer in such a way that you call A with a new and then assign it to a shared pointer object, then you will have two separate allocation, one for the control block and one for the object. Now, why is it important? First of all, because it's performance degradation. They can be in different places in memory. You can do it in different times. It also has problems that you might be allocate the object but not the shared pointer. What happens? How then the object is going to be deleted if you couldn't allocate the shared pointer which it needs to be, and so on. So there are problems with that. And therefore, we have make shared. Make shared is actually solving some of these performance bottlenecks, and in that case, you will have only a single allocation, and the single allocation will allocate your object A, the memory area, and the control block into a single place. And the rest remains the same. You have the pointer which points to the control block, and then you have inside the control block a blob, the storage area, which is containing your allocation. And with a make shared, there is only a single call, so you don't have the problems with a double heap allocation, but you have only a single allocation in that case. Now, where the things are getting interesting. What happens with the deallocation in case of a single allocation happened into the memory, especially in regard to the weak pointers? So we have the same story again. We have two shared pointers. They are both having access to the object. They increment the shared count, and in this case, the second shared pointer is actually a weak pointer. And in that case, you see that the shared count has increased and the weak count did not, or the weak count increased, the shared count did not increase. Now, when I am removing the shared object, then the shared count becomes 0, so the destructor of the object is called. But there was a single memory allocation. The control block is still owned by the weak pointer, and it's not getting deleted. So actually, from the system point of view, the memory, the entire memory, including your object memory, is still allocated in the heap. Only when the weak count goes away, the weak pointer goes away, then the delete of your entire control block and object heap goes away. This is the first thing which you have to remember when you work with shared pointers. If you use make shared, then until you have weak pointer to exist, that memory is not removed. What happens, the destructor gets called for your object when the shared count becomes 0, but the memory only recycled when the weak count becomes 0. And this could hit you in places when you allocate 30 billion pointers, for example, like in LLM networks. Now, we have another property, enable shared from this. Enable shared from this allows us to retrieve a shared pointer from an object where we have only a reference to, or when we have a pointer to that object. So if it has been allocated with a shared point, with a make shared, for example, then you can retrieve that element. How it is doing it? Well, it internally stores a weak this, which is a weak pointer pointing to its control block. And you have this weak from this call or the shared from this, and then you have a expired method on it. This expired method is checking if the weak pointer still that the expired method checks if the use count on the control block is 0 or not. If it's 0, then it's expired. If it's bigger than 0, then it's not expired. Now, the question is how this shared from or this weak from this inside your object, which is provided by the shared from this, is getting initialized. So let's take this little example. I give everybody a second to read it. I'll go through this code just to understand what's happening. So we have this A structure, which has the enabled shared from this, and I define a default constructor for it. And in this default constructor, I am calling this weak from this expired, and then I am printing true or false. And then in the main, I am just getting this make shared, and the rest you can actually forget. I'm just creating with the make shared. Now, who could guess what will be the output? Hands up if it will be is expired will be true, and hands up if is expired will be false in this case. Nobody can guess? So, expired, so there is at least one guy says false. Expired becomes true, so it is expired. Interesting. What did we learn from Scott Meyer? We learned from Scott Meyer that in the constructor, calling this is a dangerous thing. Anything with the this shouldn't be called. Apart from this, if it's casted back to your base class. Because normally your base class is already constructed by the time the current class constructor is called. So normally you should be allowed to get called. Now, where is this is expired is implemented? It's implemented in my base class. Nevertheless, it's delivering me the wrong result in my constructor. And why is that? If you look at the implementation of this make shared, this is the implementation. I copied it from the stdlib. It's a bit cryptic. Basically, one thing to know where this new is an mplace new, and this mplace new is happening in this line which I made red rectangle. And you see this create with control block happens after the new has called. And this create from control block has actually internally this enabled weak shared from this, which actually initializes the weak from this. And you can see this is after your constructor. This is a very important thing. The shared from this is not initialized from your object constructor. So, let's go further. I want to have an object which I allow only to be constructed as a shared pointer. I don't want that people can construct my object any other way. How do I make it? Everybody should know. I create a constructor, make it private, and I am making the make shared as a friend. Now, how is the make shared implementation looks like? I have it, not the make shared, but this allocate shared is more or less the make shared. As you can see, it's a variadic pragma pack. What's the story with the variadic friends? We don't like variadic friends. Actually, C++ doesn't allow you to have variadic friends. So, where is my, I should have, here. So, the variadic friends will come in C++26. And then you can do this easily. Until then, unfortunately, you have to leave otherwise. We will see in a second how. Now, what to remember? If you want to use make shared, your class constructor must be public. This has limitations, but let's go further. What if I want to manage with a shared from this an encapsulated object? So I have a object A and object B, and the object B holds a member A, and I want to have a shared pointer which is returning A. Now, actually, you can do that. So you can actually create a shared pointer which is pointing to one of your member inside. And this is called an aliasing constructor in the C++ standard, if you look it up. Now, how the object looks like in this aliasing constructor. In this aliasing constructor, the object layout will look like something this, where you have an outer object B, which has a weak from this, and then it has a member, which is the A object, which has also a base class, the weak from this. Now, what the shared pointer with the aliasing constructor supposed to do is initialize the A object weak from this. Now, guess what? It does not initialize, is it? And actually, there is no way you can initialize it. This you can consider as a bug. So if you ever want to have shared from this and using the aliasing constructor, you have no luck with the current C++ runtime. You won't have ever initialized this. Always, the created shared pointer will always return you expired. Just things to remember. Now, how you can construct the shared pointers in a meaningful way, even having a public constructor, because we see that make shared requires us to have a public constructor. So what can we do? Well, what we can do, we can add the dummy object to the public constructor, and this dummy object we can take it as a private object of my class. So nobody else is allowed to construct that dummy input parameter to the constructor because it's private to my class. So only my class can create itself. And now you can declare a static create function which instantiates this dummy object which has nothing inside, it's just there for the semantics to avoid others to able to construct you. And then you can do perfect forwarding with parameter packs to pass the rest of the members into your constructor argument list. And then you can call the create function in the bottom, like with your original set of parameters, and it will return you the shared pointer. In this way, you guarantee that this object can be only created over the static function create. Now, why is it important? Because inside the create, you construct the complete shared pointer. And there, the weak and the shared from this is initialized because the shared pointer is completely constructed. So you can use that one to do things with it, like register into a manager, like hand it around, or do many things, which you couldn't do in your normal constructor otherwise. And we reach the end of this lightning talk. So, things to remember. Make shared. The memory is freed only when there is no weak pointers available. Shared from this is not initialized in your object constructor. Classes, if you want to use make shared on them, must have public constructors. Aliasing constructor does not initialize the weak from this for the inner object. And the way how you can still use some of these things is via the pattern which I just showed you with the create function and the private dummy object. And that was it. I hope it was useful and you learned something today. Thank you very much.
Are you okay with taking some questions?
Oh, yes, sorry.
Yeah?
If anybody has a question.
Do we have any? Oh? Ah, yes.
Hello, I would like to ask why on one of the first slides weak pointer counter is 1 after construction, because it looks like a little bit strange, or is it or does it depend on implementation?
You mean here or in the beginning? This one?
Yeah, in the beginning.
So when the So the weak count, when you have a shared pointer object, this also has the shared count and the weak count incremented. And the weak pointer is only increments the weak count. So the weak count is always incremented with a shared object as well.
Okay, so for every implementation? For every possible implementation, or
the whole talk is about STD standard library implementation coming from the LLVM project. So I did not look into all the standard library implementation. Others can use completely different implementation under the hood.
Thank you.
I was wondering why it's not a good idea to have variadic friends and what the standards committee managed to solve in order to allow variadic friends from CPP 26. Do you have any ideas?
To be honest, I think it's just been forgotten. And when they introduced the parameter procs and perfect formatting, they didn't think that the friendship is needed, and it's a compiler feature. And the rest of them is a library feature, so they had to extend the compiler to have friend relationship on that.
All right, thanks.
All right, anyone?
I think I have a very basic question at first. So I don't remember correctly, but is it possible to assign a shared pointer to a weak pointer?
Yes.
So if that is true, so if you assign to a weak pointer, does the weak count increase in the shared control bulk object?
Yes, and that is the reason. So the shared pointer copy constructor to the weak pointer will increase the when the weak pointer is created, it will increase the weak count by 1, and the shared count remains the same.
Okay, but so then would it be a good practice to assign shared pointers to weak pointers, or would that be a taboo?
No, this is perfectly valid, and you do it if you want to make circles.
Okay.
So to get a weak pointer from a shared pointer over a copy or an assignment is a expected operation.
Okay, thank you.
So to add to that, it's the only way to create a weak pointer, I think, is from a shared pointer. Correct?
Yes.
Okay, anyone else? Okay, so our next talk is at 8, so we're going to take a break. So everyone can stretch your legs, get something to drink if there's still some, and see you later.